Alright, welcome to the second video. The second video is the second page of the review. I'm going to try to go as quickly as I did in the last one because I don't want you watching a video for like 30 minutes. Alright, so here it says Devon kicks a soccer ball at the wall for 60-degree angle of elevation. Ball travels 64 feet before hitting the wall. So when you're drawing a picture, anything with angle of elevation, remember you're looking up. The ball is going to hit the wall. So that means it's an elevation is drawn this way. Okay, that's my arrow showing that I'm looking up. Okay, look up. That means my angle of elevation goes there, and the ball is going to travel 64 feet before hitting the wall. Now, because I was given 60 degrees, you know I'm going to use my 30, 60, 90. Please do not use SOHCAHTOA if you are given a 30, 60, 90 triangle. So how high up the wall did the ball go? That means we're looking for X. That means we're looking for the angle, the side that's across from 60 degrees. Well, if this is 64, that means this represents 2A. So that means if 2A is equal to 64, then A is equal to 32. A represents my side across from 30. X is going to represent my side that's across from 60. That's A radical 3. Which means that if A is 32, this side is 32 radical 3. So how high up? It was 32 radical 3 feet. How far from the wall? That's this horizontal length, that's 32 feet. Please don't use any decimals if you see 30, 60, 90. Alright. Next one. So Miss Conway takes her dog Emma for a walk. She throws a frisbee. So the frisbee is being thrown up. Again, angle of elevation. Look up. So your angle should be down here. You're throwing the frisbee up. Okay, and basically it's going to go towards a tree. And the frisbee is going to land in the tree. So because of that, it's looking up is your angle of elevation. So that means when you set this up, they're asking for how far up the tree. So the tree is here. How far up the tree did the frisbee land? So we're looking for this value. And then she said that the angle of elevation is 10 feet away from the tree. It's 10 feet away from the tree. So now we're actually, because it's not 30, 60, 90, and because it's not 45, 45, 90, we're going to use SOHCAHTOA. Alright, so that means that it's going to be opposite, because that's far away, over adjacent, we're using tangent. So tangent of an angle equals opposite over adjacent, that's your formula. Tangent of 35 equals x over 10, that's your plug-in. And now cross multiply to get your answer. And we want to round to 3 decimal places. Always round to 3 decimal places. Doesn't even matter what the problem's asking, just always 3 decimal places unless it's 30, 60, 90 or 45, 45, 90. Alright, the next one, we're talking about angle of depression. Angle of depression means look down. So if Miss Sohn is standing at the top of the school and she's looking down, okay, this means look down. Every time there's angle of depression, you always draw a line that is parallel to the base. And you draw your angle here. This is the angle of depression. Remember, you're going to get a point for drawing the picture. So make sure that you draw the angle of depression in the right place. Now the angle of depression is also alternate interior to this angle. So we can place a 45 degree there. Now, this becomes a 45, 45, 90 triangle. So that means that this is, let's put that picture out again. So here's my 45, 45, 90 triangle. That means each side is going to be A, and the hypotenuse is A radical 2. Being that this side and this side are going to be the same, no work has to be shown. This is a 45, 45, 90 triangle. So that means how far is the base of the school to where the students are standing? This is the horizontal distance you're looking for. It's 45 feet. Alright, the next one, I know that this setup was kind of hard, but they said New York Avenue and 13th Street in DC form an angle of 67 degrees. So here's New York Avenue, here's 13th, they do not run parallel, they actually form an angle. So because they form an angle, you know you're going to draw something with a corner. Here's your 67 degrees. Now New York Avenue and Massachusetts, that's another corner that you're going to draw, 65 degrees. So on a map, if it is 22 centimeters between the intersection, so here's the intersection of New York, so this is the intersection of New York and 13th, and then they said the intersection of 13th and Massachusetts is right here. So the distance between those two intersections is 22 centimeters. So now that I'm done creating this triangle, I know it's not a 90-degree triangle because if I were to add 67 and 65, clearly it's bigger than 90 degrees. So I know I'm going to draw a regular triangle. And if I look, it is angle, angle, side. So I'm going to use the law of sines. Okay, so if you're not leaning against the wall, if you don't have angle of depression or elevation, clearly it's not going to be a right triangle. So it's going to be a regular triangle and you're going to use law of sines or law of cosine. So we're going to set this up. Now the thing is we can set up A and side A. We can say sine A over A. But we also need to solve for C and we need to solve for B. So I can solve for C because that's actually given to me. So I would say sine of 65 over 22 equals sine of 67 over C. Cross multiply. Divide by sine 65. And then in my calculator, I can just put this in exactly the way that I see it, making sure that my calculator is in degree mode. So I have 22 sine 67, close parentheses. If you don't close parentheses, you're going to get a different answer. Divided by sine 65. And I get 22.344. Remember, if the fourth number is bigger than 5, you have to round up. And that's why side C is going to be 22.345 centimeters. And then I'm going to do it again. Sine of A over A equals sine of B over B. Now I do need to solve for B. So I can just do 67 plus 65, which is 132. 180 minus 132 is 48. So I have sine of 65 over 22 equals sine of 48 over B. Again, cross multiply. Divide by sine 65. And then once again, I can put this in the calculator just the way that I see it. So 22 sine 48, close parentheses, divided by sine 65. Press enter, and I have 18.039. The fourth number is 3, so it can stay as 039. And those are my answers. All right, 26 is a pentagon. Remember, a pentagon has 5 sides, so 20 times 5 gives me 100 for my perimeter. I can't get the area without my apothem because you know that you have to have apothem times the perimeter in order to be able to do the area. So I need the apothem. And apothem is this line right here. And basically I don't have a value for that. So I'm going to do is I'm going to draw a dotted line. This represents my radius. My radius is going to be the same as this. It's also going to be 20. But I can't do Pythagorean theorem because the angle measurement is going to be different. You know, Pythagorean theorem, we don't really care about angle measurement. But in this case, we need the angle measurement to get the apothem. So in order to get the angle measurement, this is a pentagon. Pentagon has 5 sides. So we use this formula to figure out how many degrees are in each angle. So I have 5 minus 2 times 180 over 5, and it gives me 108. So I have 108 everywhere. But what happens is the radius is going to cut the 108 in half. So 108 divided by 2 is actually 54. So that goes there. So I know I'm looking for the apothem. I call that x. And then I need this side to help me. So that side's going to be 10 because it's half of 20. Now I'm going to use SOHCAHTOA. I have to use SOHCAHTOA because it's not a 30, 60, 90 triangle. So I have opposite over adjacent, that's tangent. Formula, plug it in, cross multiply. And I wind up finding out that my apothem is 13.764. That's going to go here. So now I can plug everything into my area formula. Because we used SOHCAHTOA, we're going to have decimals. And you know that we need to round our decimals to the nearest 3 decimal places. So I can put it in the calculator. 1/2 times 13.764 times 100, and I get 688.2. And remember that it's area, so you got to have units squared. Okay, so you will use SOHCAHTOA for every polygon except for a hexagon and except for a triangle. Alright. So again, this is a hexagon. Hexagon has 6 sides. This is the radius. A radius will always hit the corner. So if I took 2 radii and put them together, it's going to wind up giving me an equilateral triangle. Now because this is a hexagon, if I plug it into this formula, I found out that every angle inside a hexagon is 120. But what happens is we are going to have to cut this in half because that's what a radius does. It's going to cut the angle in half. And if I draw a line through the middle of that triangle, that line is called the apothem. So now I notice that I have a 30, 60, 90 triangle. So the apothem is going to be x. This bottom part is going to be half of 7, which is 7 over 2. And then this part is going to be, the hypotenuse is going to stay at 7 but we don't really need the hypotenuse right now. All we need is the apothem, which is going to follow, remember, you're following your 30, 60, 90. If A, which in this case is 7 over 2, then your A radical 3 is going to be equal to A, which is 7 over 2, times radical 3. So that's my apothem. Now there are 6 sides to this shape, so 7 times 6 is 42. So there's my perimeter. So now I'm just going to put everything into the formula, the area formula. Remember, this is not a triangle area, but this is regular polygons. So my apothem is 7 radical 3 over 2, and my perimeter is 42. Now, if you have to work with 30, 60, 90, remember we said no decimals. So you're going to put this into your calculator. Remember I said earlier, you focus on your numerator. So these are all numerators. So we'll do 1 times 7 times 42. Ignore the radical right now. And that gives you 294. Now you could throw in the radical. And then 2 times 2 is 4. Now we know they both end with a 4, so they probably can go into 4, or they probably can go by 2s. But what we'll do is we'll do 294 divided by 4. Math. Enter. And what that does, it's going to reduce the fraction for you. And it reduces it to 147 radical 3 over 2. And that's why that's my area. Guys, a lot of this is just straight algebra. So if you can't reduce fractions and multiply stuff, that's a lot of algebra. Now, if you decide to make it into a decimal, I can't mark you wrong, but I will mark you wrong if you don't have 3 decimal places. But I would prefer for 30, 60, 90, and for 45, 45, 90 that there'll be no decimals. Alright, now we're up to the back. Okay, this was the top question a lot of you forgot because you didn't see it. So this is also area of a regular polygon. So I know that I'm going to plug this in for the area. My apothem was 15 radical 3, and my perimeter was P. I'm just going to take half of this. It's okay if it's a decimal because the decimal is going to go away anyway. Divide both sides by what's in front of P. These two radicals cancel out. And then I'm left with 1350 divided by 7.5, which is 180. Now that's just a perimeter. They didn't ask for the perimeter. They asked for the side length. So a hexagon has 6 sides, so I need to take 180 divided by 6 to get my side length. So the side is going to be equal to 30 units. Okay, please don't forget units. Alright, now for the last major section, and that's going to be law of sines or law of cosines. So this whole section is law of sines, law of cosines. There are no right triangles. So if I draw this triangle, even though there's 60 degrees, it is not a right triangle. So I always label A, B, C. Little a is here, little b, little c. So A is 60 degrees, that goes inside. Little b is 12, and little c is 17. If I look, this gives me SAS, which means I need to use law of cosines. So law of cosines, they want me to solve for A, so that's the formula I'm going to use. Use what they want you to find. Whereas the other times I told you look for the bigger number or other little things like that. In this case, use what they want you to find. So if they want you to find a, you're going to use the a formula. So we have a squared equals 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 60. Remember, 1 point for the formula, 1 point for the plug-in. Great thing is you can put it all in your calculator. So 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 60. And it gives you 229. Take the square root of 229. And you get 13.132. There's a 7 here, so make sure you round up to 15, 0.133 units. Okay, so that one was a nice, easy one. Just plug and chug. Okay, the next one. Draw your triangle. And you don't have to put ABC where I put them. This is just where I put them. But they said B was 47. Big C was 112. And then little b was 13. So this is AAS. This is law of sine. So they want you to solve for C. So since they want you to solve for C, we have enough information. We don't even need to find A. It's not important for us right now. So we can say sine of B over B equals sine of C over C. So B is 47 over 13. And that's 112 over C. Cross multiply. And we get C sine 47 equals 13 sine 112. Divide both sides by what's next to C. Then you're going to put this into your calculator, just the way you see it. No arcs. So you have 13 sine 112, close your parenthesis. Divided by sine 47. And just press enter. You get 16.480, but next to there's a 9, so round up. And that's why C is 16.481 units. Okay, the next one. Draw your triangle. A, B, C. And you have A is 27. B, C is 39. And B is 54. This is ASA, law of sine. So for law of sines, I'm going to use what's given. Unfortunately, I don't have enough information to use what's given because I have a side, but I'm missing an angle. But have no fear, that's an easy angle to find. Add 27 and 39, you get 66. And then 180 minus 66 gives you 114. Now we can set it up. Sine of B over B equals, and we're solving for A, sine of A over A. Use your formula first. Now plug it in. Cross multiply. Divide by what's next to A. And then once again, you could put it in your calculator just the way that you see it. So we have 54 sine of 24 divided by sine of 114. And we get 20, whoa. Oh, not 24, it's 54 sine of 27, sorry. Okay, so we have 26.8355. Since that fourth number is a 5, I rounded up to 6. Units. Okay, so far, most of these have been pretty short, not very long or extensive on how to solve it. But the last one is going to be a little bit long because you need to do... Oh no, it won't be that long because you're only solving for the angle. You're not solving for anything else. Okay, so the last one, you're solving for capital A, which means you're solving for an angle. So if you draw your triangle, A equals 4, B equals 6, and C equals 3. Normally I would tell you to use the B squared formula. This is SSS, law of cosine. And normally I would tell you to start with B squared, but because we're solving for angle A, you're going to use the A squared. So use what's being asked. If they're asking you to solve the rest of the triangle, then you should go for the bigger number. Alright, so we have 4 squared equals 6 squared plus 3 squared minus 2 times 6 times 3 cosine A. Now you got to do each thing separately. So 4 squared is 16. Oops, no squared. You could tell I'm getting tired here. That's 16. 6 squared plus 3 squared is really 36 plus 9, which is 45. And then 2 times 6 times 3 is 2 times 18, which is 36. Do not subtract these, because if you subtract them, you're leaving this, because these are actually attached. So you can't touch the 36. So you have to actually do a two-step equation. First step is to minus 45. And 16 minus 45 is negative 29. Bring this down now. And now we want to get cosine A by itself, so we divide both sides by negative 36. So the cosine of A is equal to negative 29 over negative 36. Now since we are solving for an angle, which is a capital A, you have to use the arc cosine. Now arc cosine in your calculator is known as cosine to the negative 1. So you would say A equals the arc cosine of this fraction. So in your calculator, you go second cosine, negative 29 divided by negative 36. Close parentheses. Press enter. You count 1, 2, 3, 4. Since this number is lower than 5, we're going to leave it to 3 decimal places. So please, for the test, use 3 decimal places. I will remind you again on Monday. So no abbreviations, always 3 decimal places. Alright, so that concludes that section of the video. I am going to show you one more thing. It's a graphic organizer that will help you study for the test. But you can look at this right here and you'll see that this is when you use law of sines. Anything that starts with an A really is law of sines. And we know this is really ASS. Anything that starts with an A is law of sines. Anything that starts with an S is law of cosines. Okay, so I know that some of you are confused as to when to use law of sines, when to use Pythagorean theorem, etc. So this is a great graphic organizer. If I were you, I would copy this into your notebook or onto your review sheet. And this really helps you decide when you're going to use each one, because you have all these different triangles, but you really don't know when to use what. Right triangles are used for Pythagorean theorem, sine, cosine, and tangent in terms of SOHCAHTOA, and then your 30, 60, 90, 45, 45, 90 rule. And then you would use law of sines and law of cosines for any other triangle, preferably not a right triangle. So Pythagorean theorem is used for what? It's used to find the sides of a right triangle. The formula for Pythagorean theorem is a squared plus b squared equals c squared. You only use it to find the sides. And you use it to find the sides of a right triangle if two sides are given. Alright, and sine, that would be your sine for SOHCAHTOA. That's used also to find a side or an angle of a triangle when an angle is given. When an angle and a side are given, or two sides, etc. And the formula for that would be sine of an angle equals opposite over hypotenuse. Okay, cosine is used when a side or angle of a triangle is given, when you either are given an angle and a side, or two sides, etc. And this would be, cosine of an angle equals adjacent over hypotenuse. Tangent is the same thing. You would use tangent when a side or angle of a triangle. Use it to find the side or angle of a triangle when an angle and a side are given, or two sides. And that formula is tangent of an angle equals opposite over adjacent. Alright, now 30, 60, 90. You would use 30, 60, 90 only when you are looking for the side of a triangle, side of a right triangle. Okay, these are all for right triangles. So that formula, there's no formula, it's just a diagram. So you have 2a, a radical 3, and a. That's your 30, 60, 90. Your 45, 45, 90, same thing. If you're looking for a side of a right triangle, the diagram for this is a, and then a radical 2. Now the law of sines, it really depends. For the law of sines, you're either looking for a side or angle of a non-right triangle. So these are for non-right triangles. Okay, now there's the basic formula for law of sines would be sine A over A equals sine B over B equals sine C over C. Again, pause and rewind this video if I'm talking too fast. And then last but not least, law of cosines is when you're looking for a side or angle of a non-right triangle. So that has three formulas. We have a squared equals b squared plus c squared minus 2bc cosine a. B squared equals a squared plus c squared minus 2ac cosine b. Or c squared equals a squared plus b squared minus 2ab cosine c. Alright, so if you look at all these all these examples here, you can use all of this to help you find the answers. I'm going to leave that up to you, but this graphic organizer should help you decide when to use what. Because I know some of you were really confused in class today as to when to use law of sines and cosines and when to use SOHCAHTOA and when to use 30, 60, 90 or 45, 45, 90. Alrighty, that concludes part 2 of your video. I hope it wasn't too long. And good luck on your test on Monday. I hope you guys watched this video. Bye.